Welcome to Foundations Are Us, where we build knowledge from the ground up.
Welcome back to Foundations Are Us, where we're building knowledge from the ground up. Today we're focusing on the foundation plans for Lot 75. First, we start with the construction notes on pages 2 and 3 that we went over the other day. The siting shows all grading calculations around the house, and the two-rise sunken area that's highlighted in blue. The model type G38GM is also highlighted in orange, and we have all the details relevant to the evaluation plan. Next, the foundation plan shows structural elements in the basement, such as a 42 by 42 8 by 18 inch column pad, and it supports a measured HSS column. The stair pads, 24 by 24 by 12 inches, support the stair landings to prevent settling. Moving to beam pockets, the 42 by 42 by 18 pad has an 8 by 8 beam pocket on each side. This beam sits flush at the top of the foundation wall, and the column is centered beneath it. For electrical panels, neither our standard or alternative placement worked, so we'll place it on the porch side, the short side, past the mechanic room between the beam pocket and the basement window. Checks our controlled depths of areas for the 2R sunken mudroom be cut down 8 inches. Garages, porches also have checks to prevent water intrusion. When plans differ, for example, a 4-foot inset step versus a 6-foot 8 inset step, we follow the ground floor plan, which represents the final design. We have a discrepancy in that area where the foundation plan shows the step much thinner than the ground floor plan. In all brick models, we create a 1.5-inch brick ledge around the perimeter to ensure water drains properly throughout the weaving holes at the bottom of the brick. For utilities, the gas meter must be at least 1 meter away from electrical or exhaust sources. The hydrometer is placed outdoors with proper clearance, height, and visibility as per Ontario codes. Lastly, we remove step footings in garages for safety. We dig fully so the formwork team can work safely. That is number 1. We wrap up with the final structure weaving tile with 6 inches of coverage and on a 22 by 6 inch footing, a 42 by 42 18 inch column pad, stair pads, and the foundation wall. Thanks for joining us. Feel free to ask questions, and we'll see you the next time. And now let's dive into the details. Now we're going to go focus on the original foundation plan. This is an unmarked plan, meaning no changes have been made to it. It serves as our starting point, and it's importantly to fully understand it before reviewing any modifications. We'll begin by going over what the base plan shows and how it's intended to be built. After that, we'll move into the adjusted plan, where necessary changes are made to ensure the foundation can be installed properly in the field. On the standard foundation plan, everything is shown as basic and unaltered. There are no checks, no reverse veneer, and no modifications. Just the original layout of the home. This plan outlines the overall dimensions of the house, basement layout, including mechanic rooms and locations, 3-piece rough-ins, stair locations. However, it does not include any options, upgrades, or adjustments, and it does not show any cuts or grade-related changes. This is simply the starting point. From here, we make the necessary modifications to ensure the foundation properly suits the exterior grade and site conditions. Now we're going to look at the adjusted foundation plan. This plan has been modified to ensure accuracy and precision in the field. Concrete is very unforgiving. One small mistake, such as a misplaced structural element, can cost between $10,000 to $15,000 to repair. It is our responsibility to make sure everything is correct before anything is poured. Although this is not a cut sheet, it provides critical information about how the foundation will be built and interpreted in the field. Structural elements. We'll start with the column pads. There is a 42-inch by 42-inch by 18-inch column pad supporting an HSS column. This column carries a load from the structure above down to the footing. There is a W200 by 27 steel beam running east to west. This beam sits in an 8 by 8 beam pocket on both sides and transfers the load across the span, with columns supporting it at the center. There are also 3 stair pads, each at 24 by 24 by 12 inches deep. They support the stair landing and prevent anything from settling. Just north of those stair pads are a 3-piece rough-in, and above that is the mechanical room. Basement windows. The basement windows are 30 by 24 inches and are installed flush with the top of the foundation wall for a clean exterior finish. Lateral support details. On the left side of the house, there is a lateral support condition due to the stair layout. Because there are no floor joists tying into the top of the wall, additional reinforcement is required. To compensate, two 20M rebars are installed near the top of the wall, approximately 16 inches down. This provides the necessary support to resist soil pressure. Checks. Foundation drops. The porch is checked down 1.5 inches to prevent water from entering the home. The garage is checked down based on siding requirements, with an additional 6 inches to account for slab thickness. The mudroom is a 2R sunken condition. The beam pocket is adjusted to 8 inches by 16 inches. Reverse veneer is 16 inches down from the top of the wall with an 8-inch cut. All measurements are taken from the top of the wall down. The electrical panel location. The standard panel locations do not work for this model. All surfaces are placed at the short side of we call it the porch side. The garage side is not used, not on this project. So in order to get our panel installed, we're going to have to use the short side, the porch side, and pipe all the way down underneath the basement windows so they can still be utilized to the location between the beam pocket and the window on the left side of the drawing. This is the only place we can use, and it's the only place that's going to work. There is also a discrepancy check. There is a discrepancy between the drawings. The basement plan shows a 4-foot wide step, and the ground floor plan shows a 6-foot, 8-foot wide step. Always follow the ground floor plan as it represents a final approved design. If you're unsure, confirm with the architect. Simple as that. Summary. This adjusted plan reflects real-world construction requirements. Accuracy at this stage ensures structural integrity, proper drainage, correct elevations, and avoids costly mistakes. Always verify all details before proceeding. Now we're going to look at the ground floor plan. You'll notice that the discrepancy we discussed earlier, the 6'8" step, is shown clearly on this plan. This confirms that the ground floor plan is the correct reference to follow. You'll also notice that the home is an all brick all the way around, meaning it is an all brick model. Brick ledge is a requirement. An all brick model requires brick ledge around the entire perimeter of the home wherever the brick is installed. This is extremely important for moisture control and water protection. The brick must sit approximately 1.5 inches lower than the top of the foundation wall. This drop allows for proper drainage and prevents water from entering the home. The detail, not to scale. A small detail has been included on this slide and is labeled NTS, not to scale. This detail shows the brick sitting on a 9-inch foundation wall, a 1.5-inch drop below the top of the foundation wall, space behind the brick for building materials such as tar paper or air barrier systems. The gap allows any moisture that gets in behind the brick to travel downward. The drainage system. At the bottom of the brick, there are weep holes. These allow for water Here we're going to talk about hydrometer placement briefly. Governing framework. Meter placement is governed by the Ontario Electrical Safety Code, OESC, enforced by the Electrical Safety Authority, or the ESA, along with the local utility requirements such as Hydro One and electric utilities. Key positive compliance factors. 1. Exterior location. The meter is located outdoors on an exterior wall which aligns with the standard utility and ESA requirements. 2. Clear working space. A minimum of approximately 1 meter of clearance and are provided in front of the meter location, supporting the safe operation and maintenance and access. 3. Height compliance. The meter is positioned at an appropriate height range, typically 1.5 to 1.8 meters to center, ensuring ergonomic accessibility. Visibly. The meter remains visible from the exterior and is not enclosed within a structure or such as a porch or a room. Structural mounting. The meter is mounted on a solid exterior wall meeting durability and installation standards. 6. Separation from the porch structure. The meter is offset from the porch by approximately 1 meter, indicating an attempt to maintain separation from its structural elements. 7. Open air environment. The surrounding area is not enclosed, which supports ventilation, safety, and accessibility. General compliance intent. The design demonstrates intent to maintain clear access around the meter, keep the meter externally accessible, avoid enclosing the meter within a built structure, follow general ESA and utility placement principles. Note: final approval is subject to inspection and utility-specific requirements regarding direct accessibility and approach to path. Next, we have the front side elevations coming up. You'll notice that we've X'd out the step footings inside the garage for safety, as we do not pour with fill material in the garage. And it also shows you that it is an all-brick model, window locations, porch risers, etc. So there are some notes there as well to take a look at. This is actually the last detail of the module. It'll show you that there's a 4-inch sweeping tile wrapped around the entire house, covered in 6-inch gravel. It'll show you the depth of the pads, the 42 by 42 by 18-inch pads, the 24 by 24 by 12-inch pads, and it'll show you the strip footings and everything else that's in line with it. So, and it's showing you on a rendering of a two-story model type. So it gives you a good indication of what it looks like underground. Attached now is your builder information sheet. It kind of generally goes over what we've reviewed today. And read it at your own leisure. It'll also be in the pinned link at the comments. Thank you very much for joining me today here at Foundations for Us, where we build knowledge from the ground up. And I hope you've been enjoying these educational videos and continue to watch them and spread the word. Thank you. Have a great day.